Welcome back, everyone, for another deep dive. This time, we're heading into the hangar to explore the world of human factors in aviation maintenance.
Mm,
Yeah, we've got a whole stack of FAA research reports and incident reports to dig through.
that sounds pretty dense. What's the mission for this deep dive? What are we hoping to uncover?
Well, we always hear about the importance of human factors in aviation safety.
Right.
But I think this time we're going to really get into the nitty-gritty of it.
Okay.
You know how human actions and limitations and even the environment can actually lead to some pretty serious consequences.
Yeah, for sure. I mean, everyone thinks about the pilots when it comes to safety, but maintenance is just as crucial. I mean, those guys are the ones keeping those planes in the air.
Exactly. You know what's wild? Our sources are saying that something like 80% of aviation accidents are actually tied to human factors.
Wow, 80%. That's huge.
Yeah, it's a big number. Really makes you think, right, about all those little things that can go wrong.
Yeah, totally. Even seemingly minor slip-ups can cascade into something much bigger when you're dealing with the complexity of aircraft.
It's kind of like those mornings where you leave the house and realize you've forgotten your keys.
Oh yeah, I hate that.
Happens to the best of us. But imagine that happening when you're working on an airplane engine. The stakes are a little bit higher, right?
Way higher. I mean, the FAA even categorizes those human errors into three main types: omission, commission, and extraneous.
Okay, so omissions like forgetting your keys, you just missed something important. Commissions like putting your keys in the wrong pocket and then you can't find them.
Right, exactly.
But what's extraneous? What does that even mean?
Extraneous is when you introduce a whole new problem into the mix. Like, say you're so flustered about forgetting your keys that you spill coffee all over your laptop.
Oof.
That's extraneous, a mistake that creates a brand new issue. In aviation maintenance, this could be something like a mechanic accidentally damaging a component while he's doing a task that wasn't even needed.
Okay, I see. So it's not just about forgetting to do something or doing it wrong, but also about actions that kind of create a cascade of new problems.
Yeah, it's like a domino effect.
And those problems can be pretty serious when you're talking about planes.
Yeah, absolutely. We're talking delays at best, and, in the worst case scenario, it could be catastrophic. That's why the FAA's been really focused on this stuff,
Hmm.
trying to raise awareness about human factors. They actually came up with this concept called the Dirty Dozen.
The Dirty Dozen, what is that?
It's basically a list of the 12 most common human factors that can lead to maintenance errors.
Okay, so it's like a greatest hits list of all the things that can go wrong. I'm kind of scared to hear what's on this list.
Well, number one is a big one: lack of communication.
Hmm.
It might seem obvious, but you wouldn't believe how often breakdowns in communication between teams or even between technicians can lead to major problems.
So, like, if a mechanic notices a potential issue but doesn't communicate it clearly to the next shift, then boom, a missed opportunity to fix the problem.
Exactly.
Yeah.
Our sources actually talk about this case where a lack of communication during a shift handover led to a critical component being overlooked.
Yikes. What happened? Did the plane crash?
No, luckily they caught it before anything serious happened, but it was a close call.
Okay, so communication, check. What's next on the Dirty Dozen?
Number two is complacency. You know when you've done something 1,000 times and you start to go on autopilot,
Oh, yeah, for sure.
you miss things.
It's like when you're driving the same route to work every day and you suddenly realize you don't remember the last 5 minutes.
Exactly. Well, in aviation maintenance, that kind of complacency can be really dangerous.
Yeah.
Our sources talk about this one case where a mechanic had years of experience,
Okay.
but he missed a tiny crack in an engine component during a routine inspection. Just completely overlooked it.
No, what happened?
The engine failed during flight.
It's a good reminder to always be alert, no matter how routine a task might seem.
Absolutely. Okay, number three on the list is lack of knowledge.
That sounds pretty straightforward.
Yeah, it's not about being incompetent. It's about not having the right information or training to perform a task safely.
Okay.
Like if a mechanic's really good at working on one type of plane, but then they get assigned to a new model that they're not familiar with, without proper training, the risk of errors goes way up.
That makes sense. So it's about making sure everyone has the right training to do their job safely, especially with all the new technology that's coming out all the time.
Exactly. You got to keep up with the times. Our sources actually mentioned this case where a mechanic wasn't familiar with a specific type of fastener, and he ended up using the wrong tool,
Uh-oh.
damaged a critical component.
So even a small mistake can have big consequences.
Yeah, you got to have the right knowledge.
Yeah.
All right, number four on the list is distraction.
Oh, distractions. Those are the worst.
Yeah, they're everywhere. And in a job like aviation maintenance where precision is so important, even a small distraction can be really dangerous.
Yeah, it's like trying to have a serious conversation with someone while scrolling through your phone. You miss half of what they're saying.
You got it. Well, our sources describe this case where a mechanic was working on a pretty complex engine repair,
Okay.
and he got distracted by a conversation with a colleague. He ended up forgetting to properly secure a panel on the plane.
Oh, no.
During flight, the panel came loose and caused damage, forced an emergency landing.
It's amazing how a small thing like that can lead to something so major.
It is. And, distractions are everywhere. Okay, number 5 is a big one. Fatigue.
Fatigue. I think we've all been there.
Yeah, we have. Especially in aviation with those crazy schedules and long shifts.
Yeah.
But when you're tired, your judgment is impaired, your reaction times are slower.
You're just not on top of your game.
Exactly. And that can lead to mistakes.
For sure.
Our sources mentioned several incidents where fatigue played a role,
Really?
some with really tragic consequences.
Hmm.
In one example, a mechanic was working a double shift, and he was just exhausted.
Oh, man.
He ended up installing a fuel line incorrectly, which led to a fuel leak and then a fire.
Wow. That's terrible.
It's a stark reminder that fatigue management is so crucial in this field.
Absolutely. Organizations need to prioritize the well-being of their technicians.
I completely agree. Okay, moving on to number 6 on the list. We've got lack of resources.
Lack of resources. What does that mean in this context?
It means not having the proper tools, parts, or information to do your job safely. Imagine a scenario where a mechanic needs a specific tool to complete a repair, but it's just not available.
Hmm.
He might be tempted to improvise or take a shortcut, which could compromise the entire repair. Our sources describe an incident where a mechanic didn't have the right torque wrench. He
Oh,
tried to use a substitute tool and ended up not tightening a critical bolt to the proper specifications.
yeah.
Major component failure during flight. It's a reminder that organizations need to make sure their technicians have what they need to do their jobs safely.
So true. Okay, what's next on this Dirty Dozen list?
Number 7 is pressure. And, pressure can come from all sorts of places. Deadlines, demanding supervisors, or even just self-imposed expectations.
Yeah, we've all felt that pressure to perform.
Exactly. But when you're under pressure to work quickly, you're more likely to rush and make mistakes. And in aviation maintenance, those mistakes can have serious consequences. Our sources talk about this case where a mechanic was under pressure to finish a repair before a major holiday.
Oh, so there was a deadline.
Yeah, and he felt rushed. He ended up not connecting a hydraulic line properly, which led to a system failure during takeoff. Scary stuff.
Wow. It's a good reminder that safety should always come first, no matter what kind of pressure you're under. What's next on the list?
Number 8 is lack of assertiveness. This one's a little trickier. It's about not speaking up when you have concerns.
Yeah, it can be hard to speak up, especially if you're new to a job or if you're dealing with someone who's more senior.
Exactly. But in aviation maintenance, it's so important to speak up if you see something that's not right. Our sources describe a situation where a junior mechanic noticed a potential issue, but he was too afraid to raise it with his supervisor.
So he stayed quiet. What happened?
The issue was overlooked and ended up causing a significant delay. It just goes to show how important it is for organizations to create a culture where everyone feels comfortable speaking up.
A culture where speaking up is valued and encouraged, not punished.
Exactly. All right, number 9 on the list, stress.
Stress. I think we all know that feeling.
Yeah, it's part of life, right?
Mm-hmm.
But in aviation, chronic stress can really impact performance.
Makes sense. It's hard to focus and make good decisions when you're stressed out.
Right. Our sources actually cite this case where a mechanic was going through a personal crisis outside of work, and he brought all that stress to the job.
Mm.
He ended up making a bunch of small errors that led to a major component being installed incorrectly. The incident caused a lot of damage to the aircraft and really highlighted the need for organizations to recognize the impact of stress.
It's a reminder that we're all human, and those personal issues can impact our professional lives, especially in a high-pressure job like aviation maintenance.
Sure. Okay, number 10 on the Dirty Dozen is lack of awareness.
Lack of awareness. What does that mean?
It means not being attuned to the things going on around you.
So it's not just about what you're doing, but also about being aware of the bigger picture.
Exactly.
Yeah.
Our sources have this crazy story about a mechanic who was working inside an aircraft wheel well.
Okay.
He was so focused on his task that he didn't realize the landing gear was being retracted.
Oh my gosh, what happened?
He got seriously injured.
Wow. That's a scary example of how important situational awareness is.
Okay, we're down to the last two factors on the dirty
All
dozen.
right, number 11 is norms. And by norms, I mean those unwritten rules and accepted practices within a team or organization.
Okay, so it's like, this is how we do things around here.
Yeah, exactly. And while some norms can be positive, some can actually be really detrimental to safety.
Like if shortcuts become normalized.
Exactly. If everyone's doing it, it starts to feel okay, even if it's not safe.
And then boom, something goes wrong.
Right. Our sources talk about this case where a team of mechanics had developed this habit of skipping a certain safety check. Oh no, why would they do that?
This felt like it was a waste of time.
Hmm.
And unfortunately, skipping that check led to a serious incident down the line.
It's a reminder that we always need to be questioning those norms, even if everyone else seems to be okay with them.
You got it. Okay, the final factor on the dirty dozen is
Drumroll, please.
groupthink.
Groupthink, what's that?
It's the pressure to go along with the group, even if you know something's not right.
Oh, yeah, I've definitely experienced that before. It can be really hard to speak up and go against the grain, even when you know you should.
Exactly. Our sources describe a case where a group of mechanics were under pressure to meet a deadline, and they all decided to skip a crucial safety check.
Even though they knew they shouldn't.
Right. No one wanted to rock the boat, so they just went along with it.
Yeah.
Well, you can probably guess what happened next. The oversight led to a serious incident during the flight. It just shows how powerful groupthink can be, even in situations where safety is at stake.
It's a sobering reminder that maintaining a strong safety culture requires individuals to be willing to stand up and speak out, even when it's uncomfortable.
I couldn't have said it better myself. Knowing about the dirty dozen is a good starting point, but it's not enough. We need a way to understand how these factors actually play out in real-world scenarios. And that's where the shell model comes in.
Okay, the shell model. I remember our sources mentioning that. It sounds like a pretty powerful tool. Can you tell me more about it?
It stands for software, hardware, environment, and liveware. It basically helps us visualize the entire system of aviation maintenance.
Okay, so it's like a way of breaking down this complex system into smaller, more manageable parts.
Exactly. It helps us see how all the different elements interact and how those interactions can sometimes lead to errors.
Okay, I'm starting to get the picture. So let's break it down. What exactly does software mean in this context?
Software is basically all the non-physical stuff.
Hmm.
The procedures, checklists, manuals, regulations.
Oh, so it's the rules of the game.
You got it. And even communication protocols between team members fall under software. You know, a poorly designed checklist or unclear instructions can lead to errors, even if the mechanic is super skilled.
It's like trying to bake a cake without a recipe, right? You're bound to make some mistakes.
Exactly. Okay, what about hardware? What falls under that category?
Well, I'm guessing that's all the physical stuff?
You got it. All the tools, the equipment, the aircraft components themselves, everything you can touch.
So, wrenches, screwdrivers, diagnostic systems.
Yep, all of that.
Hmm.
If any of those tools are faulty or poorly maintained, or if the design of a component itself is prone to errors.
Well, that's just asking for trouble.
It is.
Yeah.
So hardware is all about making sure the physical aspects of the system are up to par. Okay, now think about environment.
Environment, I'm guessing that means the physical workspace where maintenance takes place.
That's right. The hangar itself, the lighting, the temperature, the noise levels.
All of those things can impact a technician's ability to focus and do their job safely, right?
Exactly. Imagine trying to concentrate on a complex task in a cramped, poorly lit space with distractions going off all around you.
It sounds like a nightmare.
It's not ideal.
Hmm.
So environment is about creating a workspace that's conducive to safe and efficient work.
Okay, so far we've got software, hardware, and environment. What about the last one, liveware? What's that all about?
Liveware is the most important one. It's the human being at the center of it all, the mechanic, the technician.
So liveware is the human element.
Exactly. It includes their physical and mental state, their skills, their experience, even their personality and attitude.
So basically all those dirty dozen factors we talked about earlier.
Bingo. The shell model helps us see how all those factors interact with the other elements of the system.
Like how a stressful environment could lead to fatigue, which then leads to mistakes.
Right. It's all connected.
So the shell model is like a diagnostic tool. It helps us understand the big picture of how human factors can impact aviation maintenance.
That's a great way to put it.
But what happens when things go wrong? I know we've got some real-world incident reports in our stack of sources. Can we dive into those?
Let's take a look.
I'm ready for some real-life examples. What do we got?
Well, one incident involved a Lufthansa Airbus A320.
Okay.
It almost crashed because of a maintenance error.
Whoa, seriously, what happened?
The investigation found that a technician had installed a component incorrectly during a routine check.
And nobody noticed.
No, it went undetected until the plane was already in the air.
Oh, wow, that's terrifying. Were the pilots able to land safely?
Yeah, they managed to regain control, but it was a very close call.
It's amazing how one small mistake can have such huge consequences.
Yeah, for sure. And it wasn't just one mistake. The investigation found that the technician actually had a question about the procedure,
Oh.
but he didn't feel comfortable asking his supervisor. He was also really tired because he'd worked a long shift the day before.
Ah, so fatigue played a role.
Yeah, there was also this pressure to get the plane ready for departure on time.
So a classic case of the dirty dozen: inaction, lack of communication, fatigue, pressure, all those factors coming together to create a perfect storm for error.
Exactly. It underscores how important it is to address all of these factors.
Absolutely. Okay, what other incident do we have? Give me another example of how human factors can impact aviation maintenance.
Okay, this one's a bit heavier. It's Alaska Airlines Flight 261.
I've heard of that. That was the MD-80 that crashed into the Pacific Ocean.
Yeah, a terrible tragedy. All 88 people on board were killed.
Oh, wow. Do we know what caused the crash?
The investigation found that a critical component in the horizontal stabilizer system failed.
What does that even mean?
It basically helps the plane stay level during flight.
Okay.
And it failed because it hadn't been properly lubricated.
Really? Something as simple as lubrication caused that crash?
It's hard to believe, right? But unfortunately, that's what happened. And again, human factors played a significant role.
In what way?
The airline's maintenance procedures were inadequate. There wasn't enough oversight to make sure these critical components were being lubricated properly.
Hmm.
And the mechanic who was responsible for the lubrication,
Yeah.
he'd been working long hours.
So fatigue again.
Yeah, and there was a lot of pressure to meet deadlines.
It sounds like a systemic failure. It's not just one person's fault.
Exactly. It's a combination of things that led to that tragic event.
It's a lot to process. What I'm noticing is that it's rarely a case of someone deliberately trying to do something wrong. It's more like a confluence of factors that creates the conditions for errors to happen.
That's a really important point.
So what can we do about it? How do we actually mitigate these risks and make aviation maintenance safer?
Well, that's what we're going to explore in the next part of our deep dive.
I can't wait. This is all so fascinating. But for now, I think it's time to take a break and let our listeners digest all this information.
Sounds good.
We'll be back soon to delve into the strategies and solutions that can help make aviation maintenance safer for everyone. Until then, stay curious.
See you soon.
All right, we're back. So in the last part of our deep dive, we went through the dirty dozen, that list of human factors that can cause trouble in aviation maintenance.
Yeah, and we explored that shell model, which helps us break down this complex system into smaller chunks, right? Software, hardware, environment, and liveware.
Exactly. And those real-world incidents we talked about
Yeah.
really make you think about how easily things can go wrong.
Yeah, it's a good reminder to stay vigilant for sure.
But now I'm curious about the solutions.
Okay.
Our sources talk about strategies for actually mitigating these risks. So how do we make aviation maintenance safer? Where do we even begin?
Well, remember that shell model we talked about?
Yeah, with the software, hardware, environment, and liveware.
Right. Each of those areas offers opportunities for improvement. So let's start with software.
Okay, software. Those procedures, checklists, manuals, all those things that guide the maintenance process.
Exactly. We need to make sure those materials are crystal clear, concise, and easy to understand.
So no more of those dense, jargon-filled manuals that nobody wants to read.
Right. We need to make information accessible to everyone. Think about simplifying the language, using more visuals and diagrams, and even incorporating feedback from the technicians themselves.
Oh, so getting input from the people who actually use those manuals every day.
Exactly. They're the ones who know what works and what doesn't.
Makes sense. It's like when a company redesigns its website based on feedback from users.
Exactly. You got to listen to the people who are actually using the product.
Yeah.
Okay, standardization is also key. Using consistent terminology, formatting, and procedures across different aircraft types can really reduce confusion and errors.
So a mechanic who's used to working on one type of plane doesn't have to learn a whole new language when they switch to a different model.
Right. It can make a big difference. Okay, let's move on to hardware. What can be done to improve the tools and equipment used in aviation maintenance?
Well, for starters, maybe we could borrow some ideas from the world of ergonomics.
Ergonomics, that's a great idea. designing tools and workspaces that are comfortable and efficient for human use.
Yeah, like a chair that's actually comfortable to sit in for hours on end, or a wrench that fits your hand perfectly and doesn't require a ton of force to use.
Exactly. When tools and equipment are designed with the human user in mind, it reduces strain, fatigue, and the risk of injuries.
Makes sense. And if technicians are less fatigued, they're less likely to make mistakes.
Exactly. Another simple but important thing is regular maintenance of the tools and equipment themselves.
Oh, yeah. Making sure everything is properly calibrated and in good working order.
You got it. You wouldn't trust your life to a car with worn-out brakes.
True. So we've covered software and hardware. What about environment? How can we create a better workspace for aviation technicians?
Environment is all about the physical space where the work happens. We need to think about ergonomics and workflow when designing hangars. Good lighting, proper ventilation, temperature control, noise reduction.
So it's about creating a space that's comfortable, well lit, and free from distractions.
Exactly. It's not just about comfort, though. It's about safety, too.
Yeah, a well designed workspace can reduce the risk of accidents and errors.
Right. We also need to think about workload management, making sure that technicians have realistic workloads and aren't being pushed to the point of burnout.
That's so important. It's about finding that sweet spot between efficiency and safety.
Exactly. Okay, now for the most crucial part, liveware.
Okay, liveware, the human element. What strategies can we use to support technicians and reduce those human errors?
Well, training is a great place to start. Comprehensive training programs that go beyond just technical skills.
Oh, so what else should be included?
We need to incorporate human factors awareness, communication skills, and error management techniques.
So giving technicians the tools to not only do their jobs, but also to recognize and mitigate those human factors risks we've been talking about.
Exactly. And training shouldn't be a one-time thing. It should be an ongoing process. Regular refresher courses, professional development opportunities.
Like sharpening the saw.
Exactly. You got to keep those skills sharp. Fatigue management is another key area we've already talked about.
Yeah, making sure technicians get enough rest, limiting shift lengths, and creating a culture where people feel comfortable reporting fatigue-related concerns.
Absolutely. And we can't forget about stress management. Aviation maintenance is a high-stress job, and that stress can impact performance and safety.
That's understandable. You're dealing with complex systems, tight deadlines, and the weight of knowing that people's lives are at stake.
Right. So organizations need to be proactive in helping their technicians manage stress, offering counseling services, promoting work-life balance, creating a supportive work environment.
So it's about treating technicians like human beings, not just cogs in a machine.
Exactly. Their well-being is essential for safety, and then there's communication.
We've touched on that before. What are some specific things organizations can do to improve communication in aviation maintenance?
Well, for starters, promote open communication between technicians, supervisors, and other departments.
So breaking down those silos,
Hmm.
creating a more collaborative environment.
Exactly. And it's also about developing clear and standardized communication protocols.
So everyone's on the same page, using the same terminology and procedures.
You got it. Effective communication is crucial for preventing errors and fostering that shared responsibility for safety. And speaking of shared responsibility, teamwork is another critical area.
Yeah, it seems like aviation maintenance would require a lot of teamwork.
It does. It's a collaborative effort, and when teams work well together, safety improves.
So what can organizations do to promote better teamwork?
We'll start by fostering a culture of mutual respect, trust, and support.
It's about creating an environment where people feel comfortable relying on each other and working together toward a common goal.
Absolutely. And organizations can also provide opportunities for team building and communication skills development.
So giving teams the tools and training they need to work together effectively.
Right. The Shell model gives us a framework for thinking about human factors, but it's up to organizations and individuals to translate that framework into concrete actions that make a difference.
It's a continuous improvement process,
Hmm.
always looking for ways to refine those procedures, enhance training, improve communication, and create a safer and more effective workplace.
Exactly. It's a journey, not a destination.
Welcome back, everyone, for the final part of our deep dive into the world of human factors in aviation maintenance.
We've been through a lot, haven't we?
We have. From those pesky dirty dozen factors
Yeah.
to the Shell model and real-life examples of how easily things can go wrong.
Yeah, it's a lot to take in, but it's important stuff.
Absolutely. But now I'm curious about the future. What's next for human factors in aviation maintenance? What trends and challenges are on the horizon?
That's a great question. And, one of the biggest trends we're seeing is the increasing use of automation in aviation maintenance.
Automation. It's everywhere these days. But what does that mean for the human technicians? Are robots going to take over the hangar?
Well, some people worry about that. But I think automation has the potential to enhance human capabilities, not replace them entirely.
Enhance. So how would that work?
Imagine systems that can monitor fatigue levels in real time,
Oh, wow.
or provide instant feedback on procedures, or even use augmented reality to guide technicians through complex tasks.
Wow, that's like having a virtual assistant right there in the hangar with you.
Exactly. And these technologies are already being developed and tested as we speak. The future of aviation maintenance is going to be this fascinating blend of human expertise and advanced technologies working hand in hand.
It's kind of like a partnership, right? Each bringing their own unique strengths to the table.
Exactly. Humans are great at problem solving, adapting to new situations, and making those judgment calls when things get tricky. And technology, well, technology excels at precision, speed, and handling massive amounts of data.
It's a powerful combination when you think about it. But all this automation, it does raise some interesting questions, doesn't it?
For sure.
About the role of humans in an increasingly automated world.
Exactly. We need to be having conversations about oversight, responsibility, and accountability.
Right.
Who's ultimately responsible when something goes wrong with an automated system?
Yeah, that's a big one.
And how do we ensure that technicians retain the skills and knowledge they need to effectively oversee these systems and step in when necessary?
It's about finding that balance, isn't it, between leveraging technology and preserving human expertise.
You got it. And it's a conversation that needs to involve everyone. Engineers, technicians, regulators, airlines, everyone.
So lots to think about as we move into this new era of aviation maintenance.
Definitely. But I'm optimistic. I think we can use these technological advances to our advantage.
Me too. It's an exciting time to be in this field, that's for sure.
It is.
Well, this deep dive has been absolutely fascinating. We've covered so much ground: the dirty dozen, the shell model, real world incidents, automation, the future of maintenance.
It's been quite a journey.
It has, and I hope our listeners have gained a deeper understanding of this often invisible world of human factors in aviation maintenance. It's a complex field, but one that's absolutely vital for ensuring the safety of air travel.
Couldn't agree more.
So, to all our listeners out there, thank you for joining us on this deep dive. We hope you've learned something new. And remember, safety is a shared responsibility. Until next time, keep exploring and stay curious.